Okay, I'm going to cover some of the more frequently missed questions on the pretest. Starting with number 1, it says state a counterexample to disprove the following conjecture. Remember, a conjecture is a statement based on observation that you think a statement that you think is true. We looked at it in the context of inductive reasoning, but we're looking for a counter example of a given statement. I had a few people ask me, what is a counterexample? All right, we're taking a pretest with an open book test. That's not a question that should have been asked if you know what how to use an index in the back of the book to look up what we discussed on about a counterexample. But a counterexample is, you make a statement like a conjecture, something that you think is true. And a counterexample is an example it's a case where the statement is not true. Okay, now number 1 is not a very good example or a very good problem, and I apologize for that. It says a hot air balloon is a device that floats in the air. The correct answer is, helium balloons also float in the air. This statement probably should have said a hot air balloon is the only device that floats in the air, or something like that. So I didn't really like this answer choice, so I gave you something more like what you're going to see on the test as an example of a counterexample. If a number is even, then it is a multiple of 4. So there's your conjecture. If a number is even, it is a multiple of 4. Okay, what are multiples of 4? 4, 8, 12, 16. They're the products of numbers that have been multiplied by 4. Okay, so is that a true statement? Can you think of an example where that is not true? Okay, so here's a counterexample. 10 is an even number. It's divisible by 2, but it is not a multiple of 4. So we have shown that this conjecture, if a number is even, then it is a multiple of 4, is false. Okay, let's move on to number 5. Refer to the following statement. 2 lines are perpendicular if and only if they intersect to form a right angle. Okay, A says, is this a biconditional statement? Okay, a biconditional statement is a result of a conditional statement and its converse being true. Definitions such as the definition of a perpendicular line can often be written as a biconditional statement because the definition is true and its converse is true. So yes, this is a biconditional statement. You can spot that with the phrase if and only if. Okay, that makes it a biconditional statement. One condition, each of these hypotheses are dependent on each other. Is the statement true? Yes, it is. Again, this is the definition of a perpendicular line. 2 lines are perpendicular if and only if they intersect to form a right angle. The definition of perpendicular lines is the basis of this biconditional statement. So that's number 5. Let's look at number 6. True or false? The converse of a true conditional statement is always true. That is false. Remember, we talked about equivalent statements. The original conditional statement and the contrapositive are always going to be true, and the converse and the inverse are going to always be true or false. Okay, so I said true initially. The conditional and the contrapositive are always going to be either both true or both false, and the converse and the inverse are always going to be both true or false. But the converse and the original conditional statement don't necessarily have to be always true. Okay, so we'll stop there for these.